over here, I'll work as developer relations at NIM. In this tutorial, we will build a simple service provider using TypeScript. Firstly, building a user client that can send messages to the mixnet, allowing us to access the mixnet through a browser on a local machine. Then secondly, build a service provider that can receive messages from the mixnet. And we will learn how to set up a pair of NIM WebSocket clients, which our application code will use to connect to the mixnet. The GitHub link to the complete code of this tutorial can be found in the description below. I'll purposely be copying and pasting the code snippets from the docs, but you can also check out the tutorial guides for further details. Make sure to like and subscribe to our channel. We really appreciate hearing from our community, so leave a comment too. For this tutorial, we want to be able to have our user client show us a simple data entry form. Once we fill in the form and press send, that data should then transmit to our service provider via the mixnet. Then we will be able to see the data we sent within the UI of the service provider in the web browser. There are a few prerequisites, such as preparing your environment by creating a new directory. We'll call this the service provider tutorial. Inside here, let's create another directory called the user client. We need to make sure we have the npm and TypeScript installed, so we'll path into the user client folder and run the two commands printed on our screen now. We can check this has all been successfully installed by looking in the folder for the package.json file. The file should look something like this. Back in our terminal, run the command printed on our screen to allow us to build the TypeScript application in the Node environment. We're going to create a new file in the user client folder called tsconfig.json and copy and paste this code from the docs. So now we're going to build the application. We want to be able to run our application on a local host. This will allow us to work on the application while it's running, and any changes are automatically shown in the browser. This can be achieved by using the parcel bundler. In our terminal, run this command printed on the screen. Once that's finished, create a new folder called source at the same level as our tsconfig.json and package.json we've previously made. Within the source folder, also create an index.html and index.ts file. In this index.html file, paste this HTML code from the docs, and in the index.ts, add this method output. We're doing this just to make sure our TypeScript file works fine when we run the application in our web browser. Let's head into the package.json file, adding this line to the script array just above the test line. Now in the terminal, let's run npm start, and you should see the following output. This will pump out a local host link we can visit, showing you the index.html file we created in the directory. Clicking on the link will open up a tab in your browser showing you the word test, and this is a good sign. In terms of building the user client, we'll be focusing on the logic in the index.ts file to establish a connection from our application to the mixnet and constructing sendable messages via the mixnet for service providers to receive. In the index.ts file, replace the console log method with the following block of code functions from the docs. The main function will act as the bulk of the logic for queuing. This is where we want to establish a connection with the NIM WebSocket client. We also want to call this at the bottom of the file so that it executes when the application is launched. The connect WebSocket URL function is where we want to return a promise which attempts to establish a WebSocket connection to the URL value. Meaning that if it successfully executes, it will notify the WebSocket client, and if not, an error will be thrown. We must implement a function that will handle document object model manipulation. This will alter the UI depending on how we interact with the application. Copy this block of code and put it before the main declaration at the end of the file. Now we need to set our variables. The OWL address, which will populate once we get a response from the initialization of the NIM WebSocket client. The target address, once we boot up the service provider's NIM client, and the WebSocket connection, which will be populated once we get a successful response from the promise within the connect WebSocket function. We can place these variables at the top of the page above the main function. Let's go back into the main function, copy and paste the code for those variables we created. Right after the async main function, we're going to add another function called send self address request. This function is called after connecting to the WebSocket and will attempt to retrieve the address to display on the UI. Now so far we've added the logic to the main function by stating the port, calling our connect WebSocket function and assigning a value that it will return to the WebSocket connection, handled any responses which come back from the WebSocket and handled them accordingly depending on what the value is presented in the type attribute within the handle response function. We're also calling our newly added function for send self address request, where we send an object with an attribute type to get the address of the WebSocket client. Started to implement a listening function for the send button, so when we press it, it will grab whatever data we want to send and send it through the mixnet. This will now be done with a new function we will now create called send message to mixnet. So now it's time to add another important function needed for sending our messages to the service provider. This will allow the function to grab the values from the data form in the index.html, insert local variables into an object that's sent to the mixnet, render our messages on the UI, and send our messages to the WebSocket. Below our send message to mixnet function, we're going to need to add another section for enabling the display of messages within the activity log section of the UI. Lastly, let's replace the contents of the index.html file with this code so it properly works with the index.ts file we've completed. Run npm start and return to the web browser, and now we can see a fresh new UI has been created for our application. The penultimate stage of the tutorial is all about connecting our NIM WebSocket client using the NIM client binaries. Let's initialize the NIM client. We should see the following output. And don't worry about the address you see in the terminal, as it will be different to the one you have. Each address generated by each client will be different from the other. Now let's run it. The WebSocket client for our TypeScript is now up and running as we see it in our browser. If you cannot, refresh the page and you should see the activity log. It shows us a successful response for the WebSocket. Thus, we are able to retrieve the same address from our terminal. We can also test whether it throws the correct error we implemented by terminating the process in our terminal. If it does this, it's a good sign of error handling. For now, we can rerun it to proceed with the next steps. This final step of the tutorial requires us to add a service provider to get the full cycle of the WebSocket functionality up and running. So we're going to start by creating a service provider folder in the root directory. We're going to open up a second terminal pathing into the service provider folder and carrying out the same steps from the prerequisite. So that will be initializing npm, installing TypeScript, installing the ts-node package, the parser bundler, creating a source folder at the same level as the tsconfig.json and package.json, and creating the two index files. Your folder should look very similar to the structure to when we created the user client. In the new package.json file we created for the service provider folder, make sure to have the start string look at the index.html and has a port set to 1235 and not 1234, so that it doesn't conflict with the user client application. Next, we need to implement the functions in the index.ts file with the following: decode stringified message. This function receives the incoming data and filters any forward or backslashes by using the string.place method. It reverses the formatting done by the stringification of our object created by the user client. Translate yes or no. We take in the boolean value as a result parameter and translate false to no and true to yes. This helps make part of the UI implemented in the index.html. Render message list, a function that re-renders a UI element in our index.html when a new valid message is received, decoded, and added to our received message data array. Handle received message. In this function, we'll call received messages. This will add a result of the message that passes through the decoded stringified message to the received message data array. We then call render message list so we can see newly received data in the received message data of the UI. And for main, just like the user client, the main function will still be in charge of initializing and executing our application. Regarding the other functions such as the send self address request, the display message, display JSON response message, and the connect WebSocket URL, we can reuse the same functions from our user client section, as we're going to be connecting to the NIM WebSocket client the same way. The service provider requires a UI, so we'll snatch the code from the tutorial guide and chuck it in the index.html file. Feel free to be creative and mess around with it. The final step of this tutorial is to get the service provider connected. Into the service provider folder, run npm start. The localhost 1235 will appear in the open tab of the browser. This window will show the service providers waiting to listen to the WebSocket connection on the port 1978, but cannot find it at the moment. Therefore, this will require us to run a second instance of the WebSocket client. To do this, initialize the NIM client with the command printed on the screen, stating a different ID and port. In this case, the port will be 1978. Then run the NIM client with this command. The second NIM WebSocket client is now running, so we can head to the browser and refresh the page and see that we've successfully received the response from the WebSocket. We can attempt to send a message from the user client to the service provider by setting the global variable target address and importing the actual address value in the user client index.ts file. Make sure you save everything and refresh both applications in the browser. At this point, you should have the following: a user client web app running, a service provider app running, 2 different NIM WebSocket clients, 2 web browser applications. Now let's give it a try. And there we go. A message has been sent from the user client to the service provider over the mixnet from creating a simple web application solution. Looking at the network topology, we see that the user client's encrypted messages passes into the mixnet to privacy enhanced data and metadata sent to the service provider. The end-to-end encryption of the NIM mixnet will always play a key role in effectively protecting any internet traffic from traffic analysis and scales no matter how complex you build your project. Thank you for watching our tutorial on the simple service provider. I hope you find this guide very helpful and take care.